Welcome back. Here I am in first hour again, trying to knock out a solution for you on today's assignment. Don't look at this until after you've tried it though. So what we're trying to do is find the volume of the solid generated by revolving different regions around horizontal lines that aren't the x-axis. So we're taking the next step in this disk method journey that we're on. Let's start by reading this one over, and we're going to sketch the region first. So our region is bounded above, I'm going to start highlighting some of these words here. So above, oh, I forgot how to highlight. Remember in the last video how I didn't know what I was doing? My other software highlights differently, but there's above. That's terrible. Let me underline. I don't even care. It's Wednesday. We're above by y equals 25. We're below by 25 minus x squared, and we're on the right by x equals 5. Okay, so I'm going to sketch the region and get my coordinate plane here first. Y equals 25 is a horizontal line. I'm going to make that black like I did up here. So here's my horizontal line, y equals 25. Don't you love it? So this is the y-axis, and this is y equals 25. And then below with green, I've got a parabola 25 minus x squared. That goes something like this. And then on the right, in yellow, I've got x equals 5, which is a vertical line there. And so the region, I'll shade this in green here. The region that we're rotating is this guy right here. Okay? And we are going to rotate about the line y equals 25. So we typically indicate that with a little curvy arrow here like this, meaning we're going to spin this thing up about the line y equals 25. If I were to sketch this, it would look something like this. Here's the region, and then when I rotate it, right, it's going to look something like that, and it's going to be all shaded in. That's my terrible attempt at drawing the solid. The point is we're trying to find the volume of this thing, and I think you'll agree if we cut the solid open, we will get a cross-section of a circle, right, if I turn that piece and look at it. And so this is a perfect candidate for the disk method. All of these problems are. So here's our deal with the disk method. With the disk method, we need a radius function r of x. And that radius, this is a typical slice here. That radius is a vertical line perpendicular to the x-axis, vertical segment. And we get the formula for that radius by doing top minus bottom. So just like our other problems, our r of x is top minus bottom. This time, the bottom is not 0, though, so we have to be careful. Okay, so r of x in our case is going to be the top, which is 25, minus the bottom, which is a binomial, so I have to include it in parentheses, 25 minus x squared. And if I simplify this thing, that's going to turn into just x squared, because I'll distribute the negative and the 25s will cancel. So my r of x is simply x squared. Now don't forget that our disk method is v equals the definite integral from a to b of pi times r of x squared. So you have to square the x squared when you set up the definite integral. I'm just noting that down here. So here's my definite integral. And let's see, we need to figure out the limits of integration. So on the left here, we've got the y-axis, which is 0, and on the right, they told me this was x equals 5. So I'm going to go from 0 to 5. I've got pi. My r of x is x squared, and I have to square that. So that's better known as pi x to the 5th. I'm going to take the pi out here, 0 to 5, x to the 4th, excuse me. It's going to be x to the 5th when I do the antiderivative. So I have to do the antiderivative on x to the 4th. That's, x to the 5th over 5. And I don't forget the pi there. And I'm going to evaluate that from 0 to 5. X to the 5th over 5. When I plug 5 in there, that ends up being 625. You have to put it to the 5th power, which is like, I don't know, 3,125. And then when you divide by 5, you get 625. So I'm just going to skip right to that. That's 625 pi. Oops. 625 pi minus, what is that going to be, 0? Minus 0. So then my answer here is just 625 pi. And I think I can highlight effectively writing that I've already done. So let's see if I can do that just to make it look fancy. Oh yeah, baby, there we go. Okay, so that's an example of finding the volume when we're rotating around a horizontal line that's not the x-axis. We are still generating a solid, right? It still has disk cross sections, circular disk cross sections. The only real concern is being careful how you get this top minus bottom, this radius function, okay? So take your time. These are very doable, but be patient with yourself and give it a go. I mean, fill everything in, draw the picture. You get stuck, you get stuck. You know that. And you know where to find me if you need any help. So in the meantime, take care.